If you've never dealt with Amazon Web Services, I'm going to make you one promise. This course is going to be mind-blowing. This course is going to be so cool, so exciting. You're going to be like, why didn't I do this before? Why haven't I thought of this before? And if you've used Amazon Web Services, I promise you that this course is going to expose you to certain things and a different way of looking at things. You're just going to learn so much to look at things differently, to look at your own on-premises data center differently and say, wow, I can really leverage that. And it will also teach you to not be afraid of the cloud. A lot of users, a lot of people out there today fear that the cloud will replace them, that the cloud will take away their jobs, that the cloud is another form of outsourcing. I'm here to tell you, the cloud is not another form of outsourcing in terms of replacing you. It is a form of outsourcing in terms of replacing the redundant hardware, rack, stack, cable, maintain facilities, yes. But the only thing that you retain when you go to the cloud is the most important thing. That's the human capital. That's the intellectual property that organizations have invested and paid for. That's you. Those resources cannot be outsourced. We still need operators and architects to design on the cloud, and that's what I want to emphasize. Let's take a look at what I'll be covering and what we'll be covering together during this entire course. We're going to talk about awesome things. How about I throw some stuff at you? An infrastructure service for the world. I'm going to show you how AWS has built an infrastructure service for the world. And guess what? You can leverage that infrastructure service for the world to deploy your applications on a worldwide basis. Yes, you can do that without necessarily having to build data centers across the globe. Why do that? Leverage AWS. They abstract a lot of things. They make it easy for you to consume certain services. Why build your own services if you can consume it easier from Amazon? And I will give you examples as we go. And I'll give you a simple example today. If you're a marketing company that uses a lot of bulk emails, you need an email server just to send a lot of bulk emails. Well, typically you would have to build an infrastructure, an entire infrastructure for that application to send emails. And you would have to worry about email reputation and how to make sure that you're not getting filtered for spam, etc. Well, guess what? Amazon has a service, for example, called Simple Email Services. That's a service for hosted applications where you can leverage Amazon's email reputation. You can leverage their email service for outbound emails. Now keep in mind, this is not going to replace your on-premises Exchange or in the cloud Exchange server. There's no mailboxes that get created here. This is a service that you leverage to send out bulk emails. You're going to find a lot of these small services that are available in pockets around the Amazon infrastructure and the services that they offer. The idea behind it is that Amazon is in the mindset of a service-oriented architecture, SOA. That's what you should be thinking about when you're in the cloud. In the cloud, everything is bits and pieces. If you need email services, guess what? There's a service for that. If you need notification services, there's a service for that. If you need queuing services for your applications, there's a service for that. If you need virtual machines, you can provision them. If you need storage, you can provision it. If you need database services, you can access them. So everything is in these chunks of services that you can consume. Not everything is on the same server. Not everything has to be built on the same server or the way that we've been building traditional infrastructures for the longest time. So keep that in mind. It's definitely it's a fresh approach at doing things, one that's very different than the way that we've built data centers in the past. So it's all about elastic computing, something that we would have a hard time doing on premises. How do I grow and shrink the environment, in a matter of minutes whenever I need, 500 new virtual machines? Let's spin them up. Well, I don't need 500 new virtual machines. I need 200 virtual machines. Well, you spin them down, right? Now you're probably saying, well, I can do this today with my virtual environment. You could, depending on how much you've over-provisioned your environment. If you've over-provisioned your environment to a capacity of 500 VMs, great, you can go up to that. But what if you acquire a company, or what if there's a new product that requires 1,000 VMs? Well, guess what? Now you have to go out, buy hardware, you have to integrate that hardware, you have to test that hardware. That'll take you weeks and months. On the Amazon Web Services platform, that'll take you minutes. So the elastic computing, the idea of being able to expand and shrink your environment is crucial. Storage in the cloud, leverage the storage. You can leverage tiered storage. You can have fast SSD. You can have a long-term archiving type storage. You can have object-based storage. There's a lot of different storage capabilities that you can leverage in the cloud. Security and compliance. Everybody seems to think, hey, we're not going to the cloud. It's not secure. But guess what? All of the major companies and enterprises that have had security breaches to this day have not had a security breach because they were in the cloud. All of their on-premises data centers have been breached. all of them, you're going to find very rare instances where a big brand name was breached in the Amazon cloud. In most cases, when you get breached in the Amazon cloud or in any other, of these large hyperscalers, it's a matter of you haven't done enough due diligence, enough work to secure your environment in the cloud. So we're going to talk about that as well. Pricing and availability. One of the biggest barriers to entry into the cloud is not knowing how to configure pricing. So if you're going to go in with the mindset of, you know what, I have 1,000 virtual machines, and you're going to take your 1,000 virtual machines and you're going to put them in the Amazon cloud, and they're going to run for 24/7, it's going to be more costly than what you have on premises today. Yes, it's not going to be cost effective. The idea behind cloud is that it forces you to rethink things. It forces you to think, do I need this virtual machine to be on 24/7? If not, I need to power it off. What are the times that I need this virtual machine to be on? That's how you're going to save money in the cloud, by doing your homework. It's not as easy as saying, I'm just going to keep everything powered on. The reason we do that on premises is because we really don't feel the costs. We have no repercussions if we keep a virtual machine powered on for 24/7. We don't account for how long or how much it takes to cool the server that the virtual machine is on. We don't take into account, well, I could power down these 100 virtual machines and then power down the hosts and do a lot of things that would save me on power, on cooling, on facilities. We don't take any of those into account, and as a result, we don't have the accountability of price when it comes to on-premises, which is why when you're going into the cloud, everything is accounted for, which is why you have to properly study your pricing. And then we get into availability. Well, today you have one data center, whereas with Amazon, I am giving you access to the world. Wherever they have regions and availability zones, you can deploy resources. Think of that. Think of that as we start to go through this course. Think of how you can expand your business. Think about what that does for mergers and acquisitions. Think of what that does for getting your compute or your resources closer to where your users are around the world. The AWS story is a fascinating one, and I'm going to show you how you can leverage it to improve your career and to build upon it. The Amazon Web Services is one of the hottest certifications out there. If you're looking for a way to differentiate yourself, then the Amazon Web Services certification is definitely the place to start. That's definitely the place to be, right? It's all about the cloud. If it's Amazon Web Services, if it's Microsoft Azure, these certifications today are hot. Amazon is on fire when it comes to cloud. Now, for that reason, I thought we'd start off with just an overview of the certifications that Amazon offers. Now, for a second there, you'd be thinking, maybe there's one certification and then I can move on. The reality is, Amazon Web Services has 3 tracks. You have a solution architect, you have a developer, and you have a SysOps administrator. Now, there's also varying levels when it comes to these tracks. You have the associate and you have the professional. The associate, it's kind of the entry level, and then you have the professional. And within these tracks, you also have different levels, right? So, for example, you start off with the solution architect, you start off with AWS Certified Solutions Architect Associate. You have one for developer as well, and you have one for SysOps. Now, when you get to the professional level, you have one that's essentially the Certified Solutions Architect Professional level. And you have one that covers both the developer and the SysOps administrator that goes into AWS Certified DevOps Engineer Professional. Now, again, these are both going to cover varying topics and varying difficulties, and they're going to go they're going to go in depth a little more as far as the professional is concerned, as opposed to the associate. Think of the associate as that administrator type entry level certification, and then the professional dives a lot deeper into things, into the design and architecture, as opposed to the operational. The SysOps administrator, for instance, that's all about helping you get certified on how to manage that particular environment, not necessarily how to architect an environment, but how to manage it, how to keep the lights going, how to troubleshoot it, how to support it. The solution architect, there you're working with more design stuff. You're figuring out what's the ideal way of rolling out this application, and then the solution administrator is the one that actually implements this. The developer, that's self-explanatory. That's for developers that want to build platforms, build applications on top of AWS platforms. Now, AWS also has a certification page dedicated to AWS certifications that I'm posting on here, and I actually want to visit that page with you. again, I'm trying to highlight here how important AWS certifications are. And if you've come like me from the Citrix, VMware, Microsoft world, this should be very familiar. I mean, again, they're trying to break it down into different solution tracks, different certification tracks, that then you can start going deeper and deeper within particular topics. Now, the reason, again, I'm showing you these certification tracks is because I want you to plot your course as far as what you're trying to accomplish, how much you want to differentiate yourself, which track is ideal for you. Are you a developer? Are you looking to be a solution architect? Are you more focused on the SysOps administrator part of things? Where is your strength? What are you trying to accomplish? The course that we're putting together is again going to cover AWS Certified Solutions Architect Associate. That's essentially the first step in your journey with AWS certifications. But it's important to understand the larger picture, understand what's out there in order for you to plot your course. Just like you would have done with the Microsoft certification, with the Citrix, the VMware, etc. You would plot out where you're trying to get to, and that would help you get there as well. So as you can see here, the AWS certification page is full of information, useful information that you can use in order to prepare, in order to take your exam. So, and you can feel free to browse this page anytime you want, make sure everything's updated. You know, these are the solution tracks, again, with the different levels and different courses. This particular course is, basically still in beta, essentially, which is why it's not highlighted in green. It's kind of dimmed out here a little bit. Now, the important thing that I wanted to draw your attention to is that Amazon certification courses are administered by Criterion. Now, Criterion has a lot of locations, many locations worldwide, so that shouldn't be a problem for you to find a location in order to take the exam. So again, I just wanted to highlight the resource that's available to you. You have resources on how to prepare for the exam. There are some sample questions that you can take. I would recommend that you visit this page and make sure everything's up to date as far as, if there are any practice exams that you want to take, and if you're looking to see if there are any new certifications that have been released, if you're looking at this particular exam, for instance, and you want to know if it's available out of beta, this would be the page for you to visit. Now, I'm sure many of you are wondering, well, Eli, what are the prerequisites for this course? What do I need to know? Can I just, if I don't have a lot of IT knowledge, can I just dive into this? So there's really no set standards as far as what you need in order to take this. There's no prerequisites for this exam that you have to pass before you take this exam. This is the exam that you would start off with. But my recommendations is for you to have a good understanding of cloud computing. A solid understanding of cloud computing infrastructure as a service in particular will go a long way in helping you be more comfortable with the material that we're going to present in this course. We're going to talk a lot about AWS, and AWS is all about infrastructure as a service like cloud computing. So a good understanding of cloud computing will definitely be important. You need a good understanding of Microsoft and Linux essentials. And what I mean by Microsoft and Linux essentials isn't necessarily just the operating system itself. While that's important, knowing Active Directory is important, knowing security and all of that stuff is important as far as the operating system is concerned. But also all the components that make up that ecosystem, right? DHCP, DNS, all of these things that make up that infrastructure will be very necessary in order for you to better understand the material that I'm going to present. Networking essentials is also important. A good understanding of TCP/IP, again, understanding of subnets, understanding of routes. Again, at the essentials level, you don't have to be a networking expert, but you need to have an idea of how networking works, because again, we're going to be implementing a lot of this stuff, or we're going to be talking about a lot of this stuff during this course. Working knowledge of virtualization will go a very long way with preparing you for this course, right? Because if you have a good working knowledge of virtualization, well, all of those concepts that you've learned, you're going to be able to apply here with AWS, except you're going to be able to do it in a different fashion, right? In a different format, but you'll be able to leverage it. You'll be able to apply it. So a good working knowledge of virtualization, whether it's Hyper-V, whether it's Zen Server, whether it's vSphere, all of this will be very helpful as well. Storage fundamentals. Again, we're going to be talking about storage in the cloud. So having a good understanding of storage will also go a long way. The understanding of the different tiers of storage. What is the fastest type of storage versus the slowest type of storage? When to use a particular tier of storage versus another will also be helpful. Again, nothing very, very deep, but an idea around storage would be very helpful. I would also recommend, as far as tools for getting started, to sign up for the AWS newsletter. Signing up for the AWS newsletter keeps you in the know, right? It keeps you updated. There's always information that goes out there as far as what's going on. So signing up for that will also be helpful. And then finally, sign up for a free account. We're going to talk about free account and how to sign up later. But again, I'm just making sure that you're aware of some of the tools that are available out there that would help you kind of start to get into that ecosystem, right? Be part of the community that you're trying to master. I just told you that you should have a solid foundation of cloud computing in order to better understand this course. But that doesn't mean that we're not going to define it and have a solid foundation upon which we can build. Now, I wanted to put that out there. What is cloud computing? 6 or 7 or 8 years ago, putting a question like this out there would have been like saying, who killed JFK? Now, it's like a mystery wrapped in a riddle inside an enigma. What did Joe Pesci say in the movie JFK? He said, even the shooters don't know. So that's how complicated cloud computing was. To the point where Larry Ellison, current CTO, back then he was CEO of Oracle, laughed at the cloud, saying basically that it was just marketing fluff. I remember writing about it in Information Week about his comments. Now, fast forward a little bit and staying with the Oracle example, you'll find that Oracle has gone on the bleeding edge of cloud computing. They're pioneering cloud computing, so much so that if you're into movies like me and you watched the last version, I think, of Iron Man 3, and when Tony Stark was in his man cave, or in his whatever you want to call it, his basement, and he was trying to render that explosion scene, you can hear in the background Jarvis saying the Oracle Cloud has finished rendering something. So they went from laughing at the cloud to kind of pioneering the cloud, to go all out from a marketing perspective as far as the cloud is concerned. So yes, 7 or 8 years ago, maybe the cloud wasn't great, but today the cloud definitely has feet, has merit, right? What I'm going to do here is we're going to go through the actual definition of cloud computing based on how NIST kind of introduces it. And NIST is the National Institute of Standards and Technology. And the way they define cloud computing, it's a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources, for example, networks, servers, storage, applications, and services that can be rapidly provisioned and released with minimal management effort or service provider interaction. Now, that's a mouthful, Eli. That's way too much for us to understand, right? What is cloud computing kind of in a digestible way? Englishize it. Put it in English for me, right? So if I was to give you an easier definition for what is cloud computing is a system. Now, what does a system mean? What does it require? And a system across all industries, in general, what does a system need? What is a fundamental block of a system? It's automation, right? And how do you achieve automation? Well, the way to achieve automation is to identify processes, repeatable processes, put them in a certain order, and then automate them. That's the only way you can automate something, is if you can find a process, a method, a methodology, and then automate that particular methodology. But automation is not the only thing that makes up cloud computing. Self-service is also another component of cloud computing. So if I was to give it my definition, it would be the automation of highly virtualized environments. Right now, that's a little more simplistic, and it requires a lot more explanation than just the automation of highly virtualized environments, right? Because self-service comes into play, an abstraction layer comes into play. So cloud computing can also be thought of as an abstraction layer. The same way virtualization, server virtualization in particular, was an abstraction layer between the hardware and the software that got installed on it, cloud computing is an abstraction layer between the data center and whatever you're trying to consume from that data center. In this case, it could be virtual servers, it could be virtual networks, virtual storage, applications, services, etc. But you're abstracting that physical aspect of a data center behind cloud computing, and you're only getting access to those logical pieces. So let's take a deeper look at the characteristics, or what is cloud computing at a glance, right? So if I was to kind of summarize it, I'd say there's 5 essential characteristics that make up cloud computing. There are 3 service models, and there are 4 deployment models. So let's dig a little deeper into all of these. So as far as the essential characteristics are concerned, for starters, it's on demand. Now that's the beauty of cloud computing. On demand, you can get access to resources. You don't have to wait for weeks to get those servers. You don't even have to wait for days to get those servers or even hours to get those servers. You want those servers, you can go in and provision them yourself. So it's on demand, it's instant. You don't have to wait for it. Broad network access means you can access the cloud from anywhere, right? You don't necessarily have to be tied to your organization's network to do that. You can do that across the internet. You can do that across the WAN, LAN. A broad network access is very, very critical for cloud computing as well. Resource pooling, that gives you the ability to have 4 or 5 or 10 or hundreds of servers, and you're pooling resources from them as far as CPU, as far as storage, as far as networking is concerned. So resource pooling is an essential characteristic, server virtualization, and also cloud computing for that matter. Rapid elasticity. Rapid elasticity means you can scale up and scale down very quickly. You need 100 servers for a week? Sure, no problem. You can do that on demand immediately right now, get 100 servers. Well, at the end of next week, you don't need these 100 servers anymore. Guess what? You can scale down, get rid of maybe 90 of those servers and stay on 10. So that elasticity, the ability for you to rapidly expand your environment or decrease your environment, is also crucial as far as an essential characteristic of cloud. And then measured services, the ability for you to measure the services that you're using, right? If you're using a particular server, and we're going to stick with servers just because it's easier to understand. If you're using it for 10 hours, then you pay for 10 hours. If you're using it for an entire day, then you pay for a day. It's that pay as you go mentality of being able to measure these particular services and paying for what you're what you're using as well. Measured services can also be related to service levels, right? So if you require a particular application or a particular server to perform at a certain level, then those can also be measured, and you can be compensated if, for instance, those service levels drop below what you've contractually agreed upon with your service provider. So measured service is crucial as far as an essential characteristic, because that's the only way that you can hold your service provider and your application owners can then hold you responsible for the performance, for the usability of the application, is through measured services. So those are essential characteristics of any cloud computing environment. Now, as far as service models are concerned, there are, the first one that we're going to be focusing on during this course is infrastructure as a service. Infrastructure as a service is, again, it's an abstraction layer between the data center. And now what's in a data center typically? Well, you have facilities, you have air conditioning, you have servers, you have networking, you have storage, you have cabling, you have all of the components that make up a data center. Infrastructure as a service is coming and saying, you know what, I am going to abstract all of that. I'm going to take away all of that complexity. You don't have to deal with any of that. You don't have to worry about facilities. You don't have to worry about security in that facility. You don't have to worry about networking, cabling, testing, nothing. Forget about all of the hardware complexity. Focus on your service. What is it that you're trying to accomplish? You need to install an Exchange server? Great. Provision a virtual server, install your Exchange application on it, move forward, forget about everything else. What they're essentially saying is, hey, we're going to abstract all the hardware, but on top of abstracting all the hardware, the reason it's an infrastructure as a service, right? And it's not a managed service where you're hosting it somewhere else and someone's managing your hardware, which is a model that we're used to. Infrastructure as a service gives you that automation and orchestration, gives you that elasticity, allows you to scale up and down. All the characteristics that we just talked about apply to infrastructure as a service, which is what makes it cloud, right? It's what cloudifies it. It's these components, that self-service, do-it-yourself mentality of being able to go in there and provision servers and applications and networks and load balancers and all of those components that you used to have to do on physical equipment in your data center in the past. Now you do it on virtual equipment that's running in a data center that you have absolutely no clue where it is. So infrastructure as a service is an abstraction layer, not just from your data center. It's the ability to also do things on demand through a self-service portal without the help of anyone else, and everything else gets automatically provisioned in the background. So it's that ability that you get with infrastructure as a service. A second service model is platform as a service. Platform as a service is when you can have your developers, again, develop the applications against a particular platform. Now, this is when we start to get into service-oriented architectures or SOAs and how different from a client-server application. With a platform as a service, the application is aware of, it's aware of the infrastructure, right? If a particular portion of the application is suffering, for instance, if the application is under load and it requires additional database services, the application can provision additional database services. If a portion of the application fails, the application is aware that a portion fails and it can redirect traffic or provision additional resources in order to support the load. So you're getting into a different dynamic with platform as a service, and it's geared towards developers that can develop, whether it's .NET or any of the other platforms that are out there, where you can develop your applications directly against a platform. And then finally, you have software as a service. Software as a service are things like Salesforce. It's the stuff that you can consume, right? You're not necessarily developing against it. You're not necessarily hosting services, as is the case with infrastructure as a service. You are consuming an application. Now, that application can be, it can allow you to build additional services, but it's already there. There's something there that you are then leveraging to create something else. Whereas with infrastructure as a service and platform as a service, these are essentially infrastructure-like services that you can then build services on top of. Software as a service is an application that's ready that you can leverage that application to create additional services. A good example, Salesforce. On the Salesforce platform or on the ServiceNow platform, you can build additional services, but that exists already. You're not building it from scratch. So those are the three service models that are available. And then let's talk about deployment models. You can deploy the cloud in a couple of different ways. You can deploy it privately, right? Now, when we say private, it could be on premises. That's, the most commonly used word for private cloud is on premises deployment of a private cloud, where you have that Amazon infrastructure as a service like deployment, but it's on premises. You can also have a private cloud in the public cloud, where maybe the idea behind a public cloud is that you're sharing resources with other organizations, and then logically you are securing those. But you can very well be on the same server or on the same storage array with 10 or 20 or 200 other customers. Well, in a private cloud, in the public cloud, you might not want to be on shared resources, so you carve out your own portion of the cloud where you ensure that nobody is on that equipment, nobody's on those servers, nobody's on that storage, and you have it hosted somewhere else in the cloud. Not as popular, and in my opinion, that's not going to be the model that's going to be popular moving forward, but that's also a deployment method that's available. So there are sort of two deployment methods when it comes to private cloud. There's the on-premises, and then there's the private cloud in the public cloud deployment. You have the hybrid, right? Now, with a hybrid model, you're able to extend your on-premises private cloud to the public cloud. So if, for example, you have a private cloud with a capacity of 100 servers, and all of a sudden you need 50 additional servers, but you don't want to necessarily have to wait 2 weeks to get the equipment and build out that extra resource within your private cloud. What you do is then you extend into the hybrid cloud, into the public cloud. That extension is the hybrid cloud, the ability to take your private cloud and essentially stretch it and build those 50 additional services that we're talking about on the public cloud platform and access them as if they were locally on your private cloud. So that the ability to do that hybrid cloud is also very crucial. Then you have community. Community clouds are also interesting. Community cloud are essentially vertical clouds. So you might see, for example, and we'll talk about this later, that Amazon Web Services has a vertical specifically for government, the Gov Cloud. You have to be a government institution in order to be able to access Gov Cloud. And Gov Cloud has a series of certifications and regulatory compliance and requirements that it meets. The same thing might happen with maybe a health cloud, right? Where you have all the HIPAA compliance, all the regulatory compliance that are necessary for the healthcare industry. Financial is another one, and so on and so forth. It's a verticalized cloud specific to a particular industry. And then you have public cloud. Well, public cloud is where you can use things like, for instance, infrastructure as a service from Amazon Web Services, right? That's where you can go out, it's shared resources. Again, you and other customers will most likely be on the same servers, on the same storage. So, again, it's that pooling of resources and the ability to leverage the scale and reach of cloud providers such as Amazon. You can't be taking a course on Amazon Web Services or on cloud computing in general without knowing some of the key dates that really shaped the history of cloud computing. Some interesting dates that you should be aware of. So I put together this list that I think you'll find interesting. So AWS actually launched back in July of 2002, except it was nothing like what we see today. Back in 2002, when it launched, it was just essentially web services. It was a way for Amazon to essentially communicate with its partners and release information via web services. It had some programmatic and developer support added to that as well, but it wasn't really the cloud that we see today, right? It didn't really evolve into that back in 2002, but it was kind of what was to come, right? But at that point, it was still supporting the retail business of Amazon. So you didn't really see the Amazon Web Services of today, but it launched back in July of 2002. It wasn't until S3 was released, and I know you're probably wondering what S3 is, and it's simple storage, and we'll talk about it later. But S3 was released in March 2006. Now, S3 was a really major release for a number of reasons, right? So S3 marked the ability for you to consume storage, right? So hence the name S3 Simple Storage. But the more important thing about S3 was the price model. So it was in March of 2006 that mentality of pay as you go, pay as you, per use, that has become the de facto standard for cloud computing payment or pricing. That was launched with S3 back in March 2006. That was clearly the first indication that Amazon Web Services was beginning to take a step forward into cloud computing and a step further away from just being known as a retailer. Now they are becoming a technology company that is catering outside of just the traditional Amazon business. So again, a key date there was March 2006 when S3 was launched. Now, in August of that same year, EC2, or the Elastic Compute, was also launched. Now, Elastic Compute is what allows you to have these virtual machine-like instances in the cloud on Amazon. That was a little more of a quieter, essentially, a release. And that left analysts a little confused as far as, well, what's the big deal really? I mean, you're just hosting servers, and we've seen this before. So again, that shows you the confusion that was going on back then in the market as far as a true understanding of cloud. And to be perfectly honest, I think even Amazon wasn't really expecting cloud computing to turn out the way it turned out. Yes, they launched this. Yes, they started to add services. They were very innovative as far as the pricing model, as far as doing things differently and for the first time. But if you would have asked someone in Amazon back then, did you really expect Amazon to be what it is today? If they would have said yes, I would have had to pull, something funny that, to argue that, because Amazon has become a beast of a cloud provider, and it would have been very difficult for them back then to truly see what they've become today. But those are two key dates again, or three key dates as far as Amazon is concerned. Now, another key date is the entry of a true technology company into the space validated that this is something to come, that this is something interesting. And that was Google's entry in April of 2008 with the Google App Engine. Now, the Google App Engine is a platform as a service that allows you to code your application, to develop your application against that platform, a very powerful platform as a service. And Google later entered with the Google Compute platform for infrastructure as a service, and etc. But in April of 2008, Google validated what Amazon has been doing, what Amazon has been saying, and that cloud computing is actually real. But all of those are nothing compared to when Microsoft actually decides to enter the market. Now, whether we like it or not, Microsoft, in my opinion, owns the enterprise as far as everything. So when Microsoft entered the market with Azure in November of 2009, that was a clear indication that cloud computing is real and cloud computing is here to stay. Now, back then, Azure was again just a platform as a service that was focused on .NET. It was later on when they started to evolve and to get into the infrastructure as a service component. So again, both Google and Microsoft entered this market from a platform as a service perspective, but they both validated the Amazon model, the Amazon message, and the Amazon vision for what cloud computing can become. So I thought I'd put these 5 dates because, again, I'm a strong believer that if you're going to learn a technology like cloud computing, you need to understand its history. You need to have a solid understanding of where it came from so that if you're having a conversation with someone, not only are you competent from a technical perspective, but you're also competent from a historical perspective that gives you a lot of credibility to understand the steps, how things have evolved, what it was like back then, what people had to overcome, what the analysts even had to overcome before we had cloud. Remember, I told you a little bit ago, it was a joke, right? Even the people, the staunchest technologists of today, the oracles of the world that are claiming cloud left and right today, back then, they were doubters. They doubted it. They mocked it before they actually embraced it and believed in it and became these pioneers in cloud computing today. So those are 5 key dates that I think are very important for you to also keep in mind. Now, I wanted to also give you an understanding of what the landscape, what the market looked like over the years as far as cloud service providers are concerned. Now, the best way to do that is to use the Gartner Magic Quadrant. If we take a look at the landscape back in December of 2010, you'll find that pretty much everyone and their grandma was on this list, and at varying levels, right? And you see Amazon was in there as well. You'll see Amazon was in there, though, in the lower right visionaries type quadrant. But you see that, they're in there. Now, it's interesting to see how this thing evolves. So if you look at it in October of 2012, almost 2 years later, you'll find that now the analysts, and we're taking Gartner in this case, but the market in general, they're starting to have a better understanding of what cloud is, and they're starting to classify these cloud providers a little better. You'll see how Amazon Web Services, shot all the way to the top right, which is where they want to be. That's the leaders quadrant. And you'll start to see how things, or all the other cloud providers, are starting to fall down and to the left, right? So again, the market is becoming clearer. Cloud is becoming clearer. Now, the interesting thing to note here is October 2012, can you see Microsoft anywhere? There's no Microsoft anywhere. Now, as of August 2013, Microsoft appeared on the Magic Quadrant. All about still down in the visionaries, but voila, they appeared, down there because, again, they were starting to, to make waves. They started to move from platform as a service and start to offer infrastructure as a service like services. And the cloud, as far as Azure was concerned, was starting to become a very strong player, a very strong infrastructure, a set of services behind it. Again, there was merit now behind it, and the analysts were starting to notice that. Now, keep in mind, you see those 2 quadrants on the right? If you compare them with what was before, look how clear and clean they are now, again, as there was more clarity in the market. Now let's take a look at one more in 2014. Now, this is July 2014, right? So if you're taking a look here, you'll find that Microsoft is continuing to make progress and is now in the leaders quadrant. Amazon is still, leaps and bounds ahead of everybody else. But at least Microsoft is a contender, and then you'll see that, look how clear this Magic Quadrant is, because now we can classify and quantify these cloud service providers in a much better way. So this gives you clarity as far as what's going on in the market as well. Now, the last thing I want to talk about here is with cloud computing, there's a shift from the traditional build and operate that we're used to the consume that we need to get used to. So what does build and operate mean? Well, for the last 20, 30 years, however long you've been in technology, you've had this mindset, this mentality that we would build and operate our data center. Now, maybe we wouldn't build the facilities. Oh, back then we were building the facilities and then hosting the equipment in them. And then we started to gravitate a little bit towards, well, let's consume the facilities from somewhere else. Let's go to a hosted provider. We'll have a cage in there and we'll still put our equipment and we'll build our data center, but we don't want to be in the facilities business. So you see how our mentality started to change as well. We went from building the facility, putting the air conditioning and worry about heating and cooling and all of that, to finding a more optimal way of doing it, which is to host our data center somewhere else. And then we kept, again, building our servers and our storage and an infrastructure, and then building the operating system and the software, the rack, stack, cable, all of that was build and operate. Well, we need to start changing our mentality to a consumption mentality, which means let's not worry about the facilities. I don't care where it's hosted. Let's not worry about the physical servers and the virtual servers and, well, virtual servers we do, but the physical servers and the physical network and the physical storage and the cabling and the racking and the stacking and the cooling and the security and all of the logistics that come with that. Let's not worry about that. And let's just worry about consumption. Do you need a virtual server? Great, go get it. How fast do you need it? As fast as you can swipe your credit card, you need it. Heck, you don't even need to swipe your credit card. If your credit card is stored, then all you have to do is basically select that particular server and it'll take minutes before it's provisioned for you. You need network? Go ahead, consume it, take it. You need a load balancer? Great. Consume it, take it, configure it. VPN? Go ahead, build it. The idea of focusing on the services. Focus on your business as opposed to focusing on being in the building and operating mentality of the last 30 years. That is essentially the difference. That is the shift from the on-premises to the cloud. Now, that doesn't mean on-premises is going away. It's not going away. It's just going to be for more valuable assets that are going to remain on premises. And then almost everything else can go in the cloud. You're certainly at a phase where we were with virtualization. With virtualization today, you say, justify a physical server, right? Well, in a few years, you're going to start saying justify putting it in the on-premises data center because it's expensive to host it there. So unless it's absolutely necessary, very high security, very important stuff, that stays on premises, maybe. Everything else, you should be able to leverage the public cloud and do it in a way where it's easier for you to consume and it's cheaper for you to consume. So again, it's a shift from the traditional build and operate and we're going to do everything ourselves to the consumption model of don't worry about the hardware aspect, worry about your services. And you can worry about your services in varying models. If you still want to build servers and desktops, even if you want to, and install applications, you can do that. But don't worry about the physical aspect. Just worry about operating system and up. If you want to take that one step further and maybe get into platform as a service, you start abstracting more stuff. So as you go down cloud computing, depending on your type of applications, depending on the type of business that you're in, you can consume cloud computing on different levels where it makes sense for your environment. Now, the one thing that I want to leave you with, do not think of cloud computing as a threat to your job. If you think about it that way, you're going to be stuck. You're going to be in defense mode. And this train isn't going to stop. You're not going to stop this wave. You can stand in front of it. It's going to run all over you. My recommendation is make yourself more valuable. And the way you make yourself more valuable, well, you're watching this course, so you're obviously smart. You're jumping on board the cloud computing bandwagon, right? You already know how to do the on-premises stuff. Now learn how to do the cloud stuff as well. So make yourself more valuable as opposed to trying to fight this wave of cloud computing. All right, boys and girls, let's sum it up. What did we talk about in this module? Well, we talked about the AWS certifications. We talked about the fact that AWS has a number of certifications available out there, and it's not just one certification that you pass and that's it. Amazon is very serious about its cloud offering. And as a result, they have built certification tracks for the solution architect, for the developer, for the SysOps administrator, and of varying levels like associate and professional. And I definitely showed you the AWS certification page, and I invite you to always visit that for up-to-date information. We talked about what is cloud computing. I gave the definition based on NIST, right? The National Institute of Standards and Technology, how they define cloud computing. We then went into the 5 characteristics of cloud computing. We went into the service models. We went into the deployment models that you have with cloud computing. The service models are infrastructure as a service, platform as a service, software as a service. Deployment models like private cloud, like hybrid cloud, like community cloud, like public cloud. We talked about all of those. We talked about build and operate versus consume. The fact that we've been building and operating the facilities, the servers, the storage, everything that goes inside, versus the consumption model of today, where we can just request what we want instead of worrying about the physical aspects. We talked about the key dates in the history of cloud computing that you should be aware of. The launch of AWS in 2002, right? In 2006, S3 and EC2, Google App Engine, Microsoft Azure. These are all key dates that you should be aware of. So we talked about all those and we covered all of those. Finally, I hope this module was very informative for you, and I'd like to thank you for viewing.